is machine learning, ML ops. Okay, let's get started. Well, what is ML engineering? So this is taken from one of the white paper written by Google. So this is how data scientists traditionally think about their ML models, right? So in the center, you'll see this big box, right? ML code. It could be machine learning training code written in Jupyter Notebook or Python script. And data scientists traditionally tend to think that model building and training is the most important part. But I think companies start to focus more on building AI and ML solutions, right? So you need to turn your ML models or whatever insight into an ML product. So from that perspective, I think things will become a lot more complex, right? So machine learning is really just a small part of the overall pipeline. To turn machine learning into production, it's actually a lot of work, and it's probably more work than you have thought about. And it involves, data labeling, collection. If you want to do real-time prediction, then you need real-time data ingestion. When you have a lot of customers or users of your web applications, then you need to build some sort of scalable inference API. So serving is very important. You obviously want to do that, at lower latency in a more scalable way, but also you want to control cost. So you need a very sound serving infrastructure in production. And after you deploy things in production, you need to monitor, how things go in production. Now we're entering the software engineering realm and DevOps as well. So data engineering is involved as well, right, in deploying models into production. So this is what the real life looks like if you want to deploy models in production. And I don't think the data science team itself will be able to solve all of these challenges. And it's team collaboration. So you need IT and DevOps or the platform team to help you build the foundation, right, the infrastructure and platform. And then we need data engineers to be helping with data ingestion, collection, feature extraction, at least automation part of it, and building feature stores. And then we need, of course, data scientists to build the AI and all the intelligence. But then software engineers or ML engineers will need to be able to deploy the model in production. They have to run testing to make sure everything runs smoothly. When it comes to machine learning engineering, it's more than just machine learning, right, or software engineering, because software engineering engineers just need to worry about the code. And when you do version control, you will version control the code using GitHub, for example, or GitLab. But when it comes to machine learning, you also need to version control the data, right? So it's a pretty complex process, and hopefully I will be able to give you a high-level overview of what machine learning engineering is and what's involved in order to do that in production. This is another way to look at it. So if you look at a typical machine learning process, it usually, of course, starts from a business problem, right? So maybe we would like to deploy a machine learning model to do mortgage or loan approval, right, through your web application. So the company might be doing some sort of online financing, and they want their customers to come to the website and put in some information, and then it's going to sort of generate some sort of loan approval, right, to see if the user will get approved right away. That significantly shortened the process, right? So this kind of platform can scale really, really fast, and a lot of users will want to use it. So that requires actually data collection in real time, right? And sometimes you need to send, to do some sort of profile matching to get any additional data you can get to enrich the features that you feed into the machine learning prediction engine, so that you can create better prediction. For example, you might be pulling the FICO or whatever credit score in real time through an API, right? But after the business problem has been defined, right? If it's credit scoring or fraud detection, obviously you would like to control the risk, but you also want this to be more profitable. And then you have to start building this kind of model to do assessment, right? It's probably a few months, at least, a few months of work. And you need to start by collecting data. And you have to build the data infrastructure in order to be able to do that. some of the biggest challenges, a startup will face is, well, we have data, but who's going to label the data, right? Sometimes the data, and then if you are going to just bootstrap and wait till you get a lot of customers using your application, and then you have enough data, let's say at least a couple of thousand data points, right? But you have to grant people the loan and you have to observe their, payment behavior. That's going to take, many, many months, right? So that is actually very challenging process, and a lot of companies will struggle to get the data labeled even. But I think if you were talking about retail, banking, the traditional businesses, I think they're abundant with this kind of signals because they usually have very powerful data lake and data warehouse. A lot of data has already been collected. Then we need data engineers to help sort of build data pipelines to prepare the data and prepare the label as well, right? So data is always, the first challenge we're going to have, and of course, we have to ingest the data because some of the applications require streaming data. So we need to have a proper infrastructure in place so that we can ingest the data in real time. We also need to have the tools that allow us to analyze the data in real time. For example, you can use Apache Flink or Spark Streaming if you have lots of streaming data coming in. And before we can build machine learning models, data scientists will probably need to do data pre-processing, data extraction, right? Data is usually extracted from some sort of data store. It could be, object store, but most likely it's going to be like a relational database or data warehouse, right? And then data scientists or data analysts will be doing data analysis, data exploration, just try to understand, the data, the shape of the data distribution, right? If there are any missing value. So this sort of give data scientists an idea how they're going to go about this this modeling process. And then the exciting part happens, right? Data scientists will be starting to develop the model. But usually you're going to train some baseline models instead of just spending all of your time on parameter tuning, because you just want to, if there are any issue with the data, you want to detect that early on. You don't want to go further down this this pipeline and then realize a week later that the data has some issue. So it's better to train some sort of baseline models, right? Just to get a basic idea of how well the model can perform before you start to do the parameter tuning. So this is the model development stage. You don't really need a fancy GPU instance, right? A lot of time you can just run that on a small instance just to develop the code, because the training, the actual model training infrastructure might be a distributed system, but while you're developing the model, it could just be a Jupyter notebook running on an EC2 instance in AWS, right? And then we start the model training. I sort of separate the model training from model development. The training here could be training on a GPU cluster, right? You've built your baseline code and you start to actually do all the training and parameter tuning. And then of course we want to validate the model, do some testing, and post-modeling analysis. And then if everything is good, but this process might actually be a few weeks or even months, right? But when everything is good, you're happy about the performance, you get the go ahead from business, let's deploy the model in production so we can start using it in the business application. Then we have to deploy the model, right? This is a stage where we talk about model packaging, model artifact storage or registry, model inference and serving. So there are a lot of software engineering stuff that's going on here. And after the model is deployed, going live, it's time for us to monitor the performance in production, because sometimes it's actually the model itself that has bugs or it has some sort of bias. And sometimes it's actually the data that we feed into the model inference engine that has issues. So we would like to set up a proper monitoring system to be able to tell that and notify the data scientists or ML engineers. But this is not a very linear process, right? It's usually iterative. So every day when the model is going live, we're getting feedback data. It's very important. And also sometimes before the model get deployed, you probably need to just go through the whole process multiple times, because what if the baseline model performance is really bad? And then you either just spend more time on parameter tuning to improve the model, or you take a step back and you think about the data. You know, is the data labeled properly, or can we get more signals or getting more interesting features collected, right? Or maybe it's somewhere buried in the data. So you need to understand the data sources very well. And sometimes the data is not available and then you have to collect the data. That's probably another few weeks and months of wait. Well, this is a typical machine learning process, right? Going from raw data, right, to model deployed in production for monitoring. And of course, machine learning engineers will work on different parts of this pipeline. And they're ML engineers who just focus more on the model deployment and monitoring side. So these are typical, these folks are typically called MLOps engineer. So they have very strong DevOps, capability, but they also understand software engineering really well. So they help sort of build scalable inference infrastructure and also model inference API, right? So you do need software engineering skills, and you need to understand how things work at scale in production. These are MLOps engineers, but in many companies, the title doesn't really matter. It's really just like what you do, right? But they're more likely to come from a software engineering background, right? They're also ML engineers who just focus more on the model development and distributed training side, and also, of course, model validation, evaluation. And these are the traditional machine learning engineers, right? In some companies, machine learning engineers will actually need to wear multiple hats. They actually built the data science model. So they work as a data scientist and they have to do all the model training and deployment. And sometimes they work like a data engineer as well. So that's what I'm going to talk about on the next slide, on this slide. So I noticed that in some companies, the machine learning engineers actually do a lot of data engineering work, right? Maybe it's because this is relatively new. And in the past, model deployment is really just done by software engineers and developers. And data scientists is sort of live in a different department, right? We start to see companies hiring ML engineers, and they're required to know many different things. And they have to write Spark code to pre-process data as well. They need to build Airflow pipeline to automate the whole data processing pipelines, and they also help data scientists deploy models. So in this kind of companies, data scientists will be still training, or machine learning scientists will be training all of these models, and it will be the ML engineers / data engineer who's automating and deploying everything. So yeah, that's why I think the job title, ML engineers, MLOps engineers, data engineers, sometimes it could be very similar. And part of this is probably because we used to have, data scientist, but data scientists can't really, do everything, right? Because originally company thought that data scientists will be helping solve all the challenges. But soon companies realize that, well, you need data scientists to have data engineering skills, software engineering skills, and a little bit DevOps knowledge as well, right? And that's why data science is becoming more specialized. And we're all doing something related to data science and machine learning. But it's actually good to see that these roles are become better defined, right? So we don't require a data scientist to know everything. And as a matter of fact, some data scientists, in the big tech companies like Facebook, they don't really build machine learning models. They're actually more working on the product analytics side. They do a lot of A/B testing, doing campaigns. They're very good with programming, of course, but they do a lot of data analytics instead of just building machine learning models. If you're trying to understand where ML engineers fit, right, in an organization, we can take a look at how data flows through the company's infrastructure, right? So in this yellow or orange box here, that's where the data engineers live, right? They start by collecting data for the company, right? Of course, the software engineers and developers, the dev team will build applications that actually attracts the customers and generates the data, right? But the data engineers will be collecting and aggregating all of these data in a centralized data warehouse or decentralized or a distributed, data store, right? Could be a NoSQL database, but many companies will be dealing with different kinds of database systems, right? When data is collected into, for example, the data lake or a staging area in the data warehouse, these are just raw data that needs to be processed, right? So data engineers will be writing a lot of scripts, Spark jobs, processing the big data, and do data integration and data transformation, right? So this is the typical ETL or ELT pipeline. And data engineers will will be getting the data ready for data analytics, right? It's either loading them into a data warehouse or just model data properly and process the data so the data is available for consumption. So that's what the data engineers typically do. And then BI and data analytics folks, right? They take the data prepared by the data engineer, and then they do ad hoc analysis to answer, to help address business questions. And they build dashboard as well. So there's a lot of analytics and insight going on in a typical data analytics team, right? And the data scientist will be working on more advanced analytics. They do visualization, they do ad hoc analysis as well. But I think data scientists, will be building machine learning models, right? And a lot of these models are actually used for batch prediction, which means, if we are predicting someone's credit score, it doesn't have to be always real time. You can generate that on a weekly basis or on a monthly basis, right? So you just need to prepare the data properly and then generate the prediction. It can be used by the business, right, over the next 30 days. That's quite common. But we start to see more real-time applications, of course, to help improve the user experience, right? On Netflix, then we need movie recommendation, or you go to Reddit, they might be recommending something as well. Amazon product recommendation, and there are a lot of recommendation systems built at Google as well, whatever Google product we built. But not just the recommender systems. There are a lot of live systems that are powered by machine intelligence, right? So in this case, the models built by the ML engineers or data scientists will need to be deployed, in as an inference engine, right? So we're essentially building APIs. If the company has a monolithic, architecture, then you probably need to integrate the models trained in Python by data scientists, and we need to export that to a proper format that can be translated into Java or C++. It depends on the backend, language, right? But if you're building, REST APIs, going with a microservice approach, then the data science or machine learning team might actually be building and maintaining this kind of inference infrastructure, right? So we'll be building some endpoints, and that endpoints can be used by other applications, right, or by the main applications, whether it's mobile or web application. And sometimes the data needs to be shared with a third party, right? Let's say it's in the online advertising world, data management companies will building user profiles, and that profile can be, can be retrieved through an API by many different kind of, DMPs or whatever, online advertising companies. They'll be making like real-time queries to get the user profile. And a lot of those attributes about a user are actually inferred through machine learning models, right? But we need to deploy the model in a very scalable way. So this is where machine learning engineers come in, right? They'll be taking the models built and trained by the data scientists, or ML engineers can just train the models themselves in some companies, and then they will need to deploy the models in production, okay? And this piece requires more engineering effort for sure, compared to data science. I came across this today, and it's very interesting. And it's the Pokemon of data science. So as you can see, I think what I learned from this, right, is basically saying that data scientists, this is, what we used to think about data scientists, but this is getting more specialized. We have MLOps engineer, we have data engineers, right? Analytics engineer, who work more with the modern data stack, Snowflake, things like DBT, and there's ML engineers, right? But in some companies, MLOps engineers and ML engineers might be the same role. So it's kind of interesting. I thought I would share with you guys. All right, let's talk about the trend and job market. If you search, MLE or MLOps on Google Trend, this is what you will see, right? MLOps is definitely picking up really quickly in the past few years, and machine learning engineering is growing. I think maybe eventually these will be two different roles, right? And data scientists somehow will merge with machine learning engineering. And then MLOps could be a very different role. But at this point, I think it's a little bit confusing because in some companies, the title is just ML engineers, and you have to do a lot of DevOps and software engineering as well. And in some company, it's the other way around. If you look at the skill set, right? And this chart here just compares the different kind of skills required for different data-related jobs, right? And as you can see, machine learning engineers, Python is important, and 44% of the job postings on Indeed. I think we collected a few thousand job postings, and 44% of them will mention Apache Spark. Because a lot of times ML engineers will need to build end-to-end pipelines. That means they might be actually doing some data engineering, and it requires big data skills as well, right? Because the raw data is usually much bigger than the data set data scientists will be dealing with. And in production, many companies will be using languages such as C++ and Java, right? Especially, I think, in the banks, a lot of banking systems use, Java. And you'll see C++ as well, and of course TensorFlow and PyTorch. This is a little bit outdated. I believe PyTorch is probably more popular than TensorFlow now, but that gives you a basic idea, and some of the important skills you need to have to work as a ML engineers. So I'll break it down for you later. Now, if you look at the job market I collected some data from different kind of websites, so take it with a grain of salt, right? It really depends on the level, but I think it's pretty consistent. So I visited, or I collected data from Glassdoor, Levels, Indeed, and Hire.com, and looks like the average salary for a machine learning engineer is around 150,000 US dollar, and it's between 120 and 130,000 Canadian dollar in Canada. But if we're talking about the big tech, I've seen more salaries reported, which is higher than 300,000, but that's probably the total compensation. But it could go as high as 800,000, even over $1 million in some companies, but that's probably staff level engineers. Well, this is pretty encouraging, definitely well paid. And I think ML engineers on average will earn 20,000 to 30,000 more than data scientists, probably because they are required to have stronger engineering skills. Okay, so let's talk about the learning path, right? Assuming you're interested in machine learning engineering, but when you start to do some exploration in this field, I think very soon you'll get overwhelmed because the landscape is, pretty massive, and there's so many different things you need to learn as a machine learning engineer, and sometimes you just don't know how to get started. I have two different views. I think to understand what it takes to become a machine learning engineer or MLOps engineer, first you need to understand how the end-to-end pipeline works, right? I showed you a different view, right? Starting from data to data ingestion to data analysis, modeling, and deployment. This is taken from a paper published, I think, maybe end of last year. So you can go to this link to read the paper, and it's pretty interesting. But it explains the overall process of ML engineering. It's similar to what I just described with more details, right? So as you can see, it goes from top to the bottom, right? And it usually starts from a business problem, right? And then we have to define ML problem and then start to collect data, right? So B1 is basically the requirement gathering for feature engineering. So that includes, things like data ingestion, just figuring out where data is, right? So data can come from real-time streaming data or batch data already stored in the database or through an API, or sometimes data is, stored in the cloud. And then data engineers will be connecting to the raw data through some sort of connectors, right? Extract the data, and they will be doing data transformation, right? But the requirements will probably need to be defined upfront. And sometimes, it's iterative process because the data scientists will need to do experimentation to see which feature works, right? And which feature don't work. So that's the data transformation, cleaning, and also feature engineering process, right? And then we'll move on to the experimentation stage, which is the step C here, right? Because before you deploy models in production, data scientists usually spend a few weeks or sometimes even months, right? But it could be just days. Doing experimentation, building different kinds of model, right? Doing sampling, just structuring the data in different ways and try different modeling approaches, parameter tunings, well, until they get a model that they're happy with. The performance is good, validation results is great. And then data scientists or ML engineers wanted to export the model, right? Because we would like to save the model artifact, and you have to decide what format you're going to save the model in, right? And then the model will probably need to be version controlled and saved somewhere, and it's typically a model registry, right? And the next step is actually starting to, building the model inference pipeline, right? So the model will need to be served. That means we need to build inference and model serving infrastructure, and to start building, inference API, right? And this involves CI/CD as well, because when we deploy models in production, you have to do some sort of continuous, integration. You have to do testing as well, right? So you have to build, test, and push the model artifact because you want to do automated process, right? And the model artifact will be pushed to a registry somewhere, right? It could be Amazon S3, right? Or it could be a specialized, model registry tool. Right? And once the model is deployed, we need to start, serving the models in production, right? So in production, you need to have the feature ready. The feature is either pre-processed and saved in the feature store, or based on the user activities in real time, you just need to have some sort of real-time, data ingestion, right? Process. So from your application, the data could be ingested into or saved in the offline database. So this is like a batch process, right? So the latency will be a little bit high. But we can have online database such as a NoSQL database like Cassandra, right? It could be Redis, in-memory data store. And then it kicks off, right, your model prediction process, okay? And once the model is in production and starting to, spit out real-time prediction, we need to monitor the process as well, okay? To detect, feature drift, and also you need to take the fairness into consideration as well. So there are a lot of different concepts you need to know, but sometimes you just work on, a part of this pipeline, right? It will be great if you can work in a role that requires you to do so many different things, but I think it will take some time for you to get there if you're just, getting into this field. And of course, you can choose to specialize because it's almost impossible to learn all of these from scratch within, let's say, 2 months, right? It's going to take some time. So I'm suggesting a learning path. So WeCloudData has a machine learning engineering bootcamp, which runs for 6 months. So we're in the process of producing a ML engineer career guide. It's like a bunch of blog posts, so you can read that in more detail. But before that's available, let me share our machine learning engineering bootcamp curriculum with you. Okay, so you can follow this to learn more about machine learning engineering on your own. So first of all, we need to make sure that we know, machine learning and deep learning, of course, right? A lot of the exciting development area of machine learning is actually in natural language processing or computer vision. So I think working as an ML engineer, you will definitely need to understand the end-to-end process of machine learning, and understanding different algorithms will be important as well, because some ML engineers actually focus on deep learning, right? And of course, after you've learned machine learning and deep learning, we'll move on to MLOps. So I think the prerequisite to ML engineering is that you need to know machine learning, the fundamental skills. You need to build the fundamental skills first. So that includes, understanding classic machine learning algorithms, right? They're still very popular in the industry. I don't see deep learning taking over everything. In heavily regulated industries, companies are still more likely to use a traditional method that's easier to interpret. And when I talk to a lot of the machine learning engineers or data scientists who work in the field, they will tell you that they tried deep learning, but it's just not always going to beat a traditional method in real life. And it really depends on the use cases. If we're talking about computer vision, natural language processing, I think nowadays it's a no-brainer. You have to use deep learning, reinforcement learning. But if we're dealing with more structured data, right? Data that you collect from, let's say the banking data, retail industry, or telecommunication, or even mining industries. I think we have an instructor who works as a very senior machine learning leader in a mining organization, and they've tried to deploy machine learning models for detecting, right, different kind of, rocks. And it's pure computer vision. They tried a lot of deep learning, convolutional neural networks, and sometimes it didn't work out better than the traditional methods or even just using OpenCV. So understanding classic machine learning algorithm is very important. I need to understand regression, classification basics, and unsupervised learning as well. And feature engineering, feature selection is also very important when you deal with structured data. And of course, how to evaluate, models and do parameter tuning and understand how to build the end-to-end pipeline. That includes like data pre-processing. Okay, so this is the prerequisite, I would say. And then, of course, we would like to learn deep learning neural networks. So you need to understand the basics of neural networks, right? And understand how to, or learn how to implement a basic neural network using stochastic gradient descent yourself, right? It's important to understand, you don't get to do this a lot when you start to work with packages, but I do think that, you need to understand how things are optimized, right, at a lower level. So that's the basic neural networks. You learn how to work with PyTorch, APIs, and then you move on to the actual use cases, right? Computer vision, then you need to understand, convolutional neural networks and many different types of architecture. And it's the architecture that matters more than the algorithm itself, right? And then some of the applications of computer vision, such as object detection, segmentation, transfer learning, and of course, fine tuning, because the cost of training large models is very high. And most of the company can't really afford that, right? So that's why I think the industry is moving towards foundational models, which means companies like Facebook, OpenAI, Microsoft, Google, they will be building these large models, just like ChatGPT, which is based on large language models, right? And the cost of training the model is like millions and millions of dollars. So we'll be doing like transfer learning and doing fine tuning and tailor that foundational models to your own use cases. And a lot of companies find success in that, right? And then, of course, generative model is becoming more and more interesting. Things like, style transfer, colorization, all very popular. So that's computer vision. Natural language processing is probably the hottest topic right now. I think before you move on to, GPT-3, ChatGPT, knowing the basic text processing is very important because you're dealing with a lot of text, right? You need to understand like how to pre-process data, just like how we use pandas to process structured data. You need to understand how to process, basic text and understand the traditional NLP methods as well. And a lot of times the basic methods solve your problem, right? And then you need to move on to the basics of embeddings and recurrent neural networks such as LSTM, sequence-to-sequence models. But of course, transformers, GPT generative models are really taking over as some of the most popular methods. So attention mechanisms, generative models are definitely something worth your investment. But also try to learn some of the real life application. For example, search engine is something we teach in the program. We teach Elasticsearch because you can just find so many use cases. When you search for jobs on Indeed, it's using technologies such as Lucene and Elasticsearch, right? You go to Ticketmasters and searching for some events, it's basically a search engine. And Google and Bing, these are the the biggest use cases, right? So yeah, search engine. A lot of companies will build the internal like enterprise search applications. Now I think it can be powered by ChatGPT as well. But it's a pretty exciting field. I think ML engineers will definitely want to learn some of these skills. In our program, we will ask the student to build at least complete at least one computer vision or NLP capstone project depending on their interest. But students can work on both as well. Now, after all of these are covered, I think it's time to move on to the machine learning operations, right? Well, this is the sequence I would recommend, but it doesn't mean when you're doing self-paced learning, you have to finish all of these. Let's say if you are more familiar with the traditional classic machine learning algorithms and you would like to learn how to deploy models, you can jump to MLOps right away because they don't overlap that much. You can pretty much take a pre-trained model, right, that you find on internet or find on Kaggle, and it can try to deploy that. So these can be learned separately. When it comes to MLOps, we break it down to 4 different categories. So there's data engineering, model engineering, software engineering, and DevOps, right? So on the data engineering front, you need to learn a little bit about data infrastructure, right? AWS is infrastructure for the cloud, but you need to understand the data infrastructure piece, right? If you want to collect data, you probably want to run that on a AWS EC2 instance, right? So you need to know how to launch a virtual instance in the cloud. Or if you're doing big data processing, then the Databricks and Apache Spark framework, that's something you need to know. You need to understand how to build data pipelines, because don't expect the data to be clean and prepared for you. As an ML engineer, a lot of times you have to write scripts to pre-process the data and build some sort of data pipeline as well. And then feature store, right? Ideally, these are done by the ML engineers who actually work on a production site, right? But this is data engineering skill that I think ML engineers need to have. And also data quality control, right? Working with packages such as Great Expectation, or even just doing unit testing, right? Whatever transformation function you write in Spark, for example, you want to write some test cases to make sure that the function takes in some sort of input and always spit out the correct output, right? So that's the data engineering skills you need to have, and then you need to learn model engineering. So this is very much related to machine learning, right? Feature engineering. But as data scientists start to build more models in real life, like for one machine learning project, you might be building like 50 different types of models, and most of these are experimentation, right? Some models work better. Most of the model, are not really great performance. So in that case, you want to track different kind of experiments or some experiments, because you may want to come back later, right? And then you just forget about what you did like three weeks ago. This is some sort of documentation process, right? So for example, MLflow allows you to, is a project, open source project that allows you to sort of track your machine learning experiments. So it not only saves the code, right, to GitHub, it helps you identify the data sources, the version of the data used for training a specific model or for one specific experiment, and it saves the model artifact, right, and even help you, save the model in model registry, right? And it can use that to deploy the model. So MLflow has a lot of features, but most companies will want to use it for experiment tracking. And then model packaging, right? How do we package the model so that before we deploy the model, right? What format do we choose? It also depends on the model inference, infrastructure and model registry as well. These are just extension to your data science machine learning process. And then the software engineering process will probably kick off, right? Because now we are talking about serving the model in real time, and then you need a serving environment, right? So most of the models are probably deployed in a Docker container, but you can serve the model in a serverless fashion using Amazon Lambda function. It works for some use cases, right? The cost might be quite high if you have large traffic. And sometimes you can just deploy the model. But let's say you don't like the cold start problem with Amazon Lambda. And over time, you would like to save cost. So you can just deploy the model in a Docker container, but you still want to deploy that to the cloud. So you might be running that on ECS, Elastic, Container Service. And for some use cases, Kubernetes might be an overkill, right? If you only have a few small models. And then you need to know how to build inference API, right? Using Python fast API, using Java, or you can even leverage managed services such as Amazon SageMaker, which can help you deploy models pretty easily, but cost is an issue, right? If you can afford it, that's great. But if you're building large applications, I think using a managed service might be quite expensive, but it's very easy to help you get started, right? Deploying model in production also means that you need to do a lot of testing, right? The unit testing, integration testing. And the testing is not just the code and the prediction function, it's also the data, right? You want to make sure that data that gets fed into your inference engine has the right shape, has the right distribution, right? If the upstream data engineering process produce some bad data, I'd say on average, customer base, the gender distribution is 50-50. And all of a sudden, one day, the gender distribution becomes, 90% versus 10%. So obviously something got screwed up, in the upstream data engineering process, right? And that may actually cause some issues, but not always, right? All right, and then DevOps, because we're talking about deployment, we need a deployment environment, we need the infrastructure, right? So do we do this in a Docker container and then put that on a AWS, EC2 instance, or maybe the company is building a lot of applications, so you already have a Kubernetes cluster, so you just would like to, deploy the model to the Kubernetes cluster, right? So you need to have a little bit of knowledge about that, but I don't think the ML engineer need to be an expert of DevOps, but you do need to have very basic understanding or even to intermediate level understanding of DevOps, right? You need to understand how to automate your ML pipeline. If you're deploying everything in Kubernetes, there's one project which is called the Kubeflow. You might be able to leverage that. And then CI/CD, you want to do automated deployment, right? And when you deploy models in production, there are different types of strategies. So in to learn deployment strategies, this is kind of similar to the traditional software engineering. And then when the model is deployed in production, monitoring is very important. There's some open source projects and some paid services out there that help you do model monitoring. So that's something worth looking into as well. And then, of course, you need to build some sort of end-to-end MLOps, ML engineering capstone project to use that as your portfolio project for job search, right? So this is a quick rundown of the learning path we would recommend to anyone who wants to become a machine learning engineer. But just keep in mind that when you learn MLOps, ML engineering, don't just focus on the machine learning piece, right? You need to understand a little bit data engineering. You need to understand model engineering, software engineering, and DevOps as well. So I covered that in the previous slide already. Now, if you understand the process alone, that's not enough. You actually have to know how to work with many different tools, right? Now, in the tooling ecosystem, that is very overwhelming. It's very messy. But there are some tools I would like to recommend. You don't need to know all of these, of course. Some of these are competing products, actually. But on data engineering side, for example, data lake and data warehouse. Now, this is more data engineering related, right? But ML engineer at least need to know where to retrieve the data. because some companies might just be using Snowflake as their feature store, right? Just this is where you store all of the features. If you're doing batch prediction, right? Data might be retrieved from a Snowflake, a data warehouse, for example, and data can come from Amazon S3 buckets, from Delta Lake, Data Lake, right? For quality control, right? Great expectation. For data, running data queries or data retrieval and processing, then Apache Spark is very popular if the company has big data, and a lot of data scientists work with pandas, but it's sort of not very scalable, right? If you have small data set, that's great. In production, Spark is probably more likely to be used when companies have big data, or simply SQL, right? So dbt can be used to prepare data for machine learning as well, right? And on data engineering side, data labeling is also very important. You can work with Amazon SageMaker. SageMaker has data labeling service, or you can work with a dedicated data labeling service, which is usually quite expensive. But of course, if you want to do this at scale when you have the volume, you can get bigger discount. Labelbox, Scale AI, these are some of the better known company that actually does a lot of labeling for companies like Tesla, right? And then feature store, of course. How do we store and version control the data, right? In production, and the data will be retrieved from these feature store for real-time inference at scale. So feature store is becoming more and more, important concept. You don't have to have a feature store, but having one is definitely going to be very useful if you train and build a lot of models. But if you only have a handful of models, maybe it's not necessary. But there's always pros and cons, because the engineering cost is also pretty high if you want all of these great features in your ML pipeline. And then on the model training and evaluation side, of course, there are many different types of packages and frameworks, right? TensorFlow, Scikit-learn, Keras. Ray is something I highly recommend you look into. It's a much more scalable version of Pandas and Spark, right? It's very exciting technology, actually. They got a lot of funding as well. So look into ray.io. And on the model tuning and training side, there are some, hyperparameter tuning services. On the packaging side, Onyx is a great format for you to do, language agnostic, some, sort of model packaging format. MLflow can be used for model packaging as well. But MLflow is probably better known for model experimentation, but there's weights and biases as well. SageMaker has its own experimentation tool. And model registry, there are different software or services out there, such as DVC, data version control. It can be used for model registry as well. And SageMaker has its own registry. So that's the model engineering side of things. And when it comes to software engineering, model serving is a very big topic, right? That's a very important piece. Python is a great way to get started, for learning purpose, right? Working with Flask and Fast API. Fast API is, supports async, which is great, but Python is not really well known for, being particularly fast, right? So if you are not coming from Java and C++ background, you can still train the models, right, in Python, and you can just save that in a better format when you do model packaging. So the model artifact can be used in many different types of languages, right, to be used in production. But you can leverage managed services as well, such as the Kserve, Kubeflow, and Seldon. Seldon is a commercial tool. I don't think it's open source. A lot of companies use it to deploy machine learning models. And models can be deployed in a serverless fashion as well. So you can use, API gateway plus Lambda in the AWS ecosystem to deploy a model, and that serves a specific use case as well. And then model testing, unit testing, in the dev environment. I think you need to be very familiar with GitHub. adopt a proper IDE, I would say, using VS Code is probably better. A lot of data scientists come from a Jupyter Notebook environment. They're very comfortable with Jupyter Notebook. It's great for experiments and development purpose because you can easily visualize, do a lot of visualization. A model building process is very interactive, right? But when you deploy things in production, writing Python script is probably better. So you need a proper IDE, and you can do a lot of the testing. But there are people who just prefer to work with Jupyter Notebooks. I think if you take some courses from Fast AI, Jeremy probably, prefers to work with Notebook. And then they even created a tool called MBDev, which I think is pretty cool. It converts your Jupyter Notebook into into Python code, but it has a lot more feature. So look into that if you prefer Jupyter Notebooks. And if you work with model deployment in Amazon SageMaker, it has some sort of Jupyter Notebook environment as well. So it depends on like the team culture as well, I guess. If your team has a stronger dev environment, I think most likely you'll be working with VS Code instead of Jupyter Notebook. For model training experimentation, definitely Jupyter Notebook is great, and Colab as well. And then on the DevOps side, there's so many things you can learn and practice as well. First of all, understand infrastructure. Knowing how to set something up on AWS and Google Cloud or Azure, right? You don't have to become Kubernetes expert. That's something I would probably recommend learning at the last step. So get comfortable with Docker first, right? Because a lot of data scientists and ML engineers will be required to save the model in a Docker container. So, and then you give the container over to the dev team if it's, if that's the environment you work in. But if for a company, for ML engineers, you probably need to just build everything in a Docker container and then deploy that using the container as well, right? You need to understand CI/CD. So in the AWS ecosystem, there's a specific set of CI/CD tools, but you can use GitHub Actions, you can use Jenkins. So there are lots of tools to choose there as well. For automation, if you are doing this in a serverless fashion, then AWS step function is something to consider. Probably not the best for machine learning purpose. Apache Airflow is built for data engineers. I see a lot of companies using it for building ML pipelines, but it's probably also not the best tool for that. There's some interesting open source projects out there. You can use Amazon SageMaker as well, of course. On the monitoring side, there's some projects such as Fiddler, Evidently.ai are something worth exploring. But some companies just use traditional tools like, Amazon CloudWatch, Grafana, just a traditional monitoring tool. So this is an overview of the landscape. There's so many different tools. There are way more tools out there, and I think after the recent tech layoff in 2022, you're probably going to see more and more startups, right, building ML ops and AI ops capability. So you're definitely going to see more tools popping out. But overall, I think it's good for the ecosystem. All right. I believe this is the last slide before we start to do the AMA. So I think my recommendation for anyone who's thinking about getting into ML engineering or ML ops, it's important to build a project that's a little bit more end-to-end, right? So this is just one example for Amazon SageMaker, right? But it usually starts from data. So try to find a useful data set, right? And step one is to do some ETL, right? For example, using Apache Spark on a Spark cluster. In AWS, you can use EMR. After you pre-process the data, you need to save the features, right? Let's say you're building ML features, doing some sort of feature engineering, pre-processing, you save the data back to S3, right? And that data will be used for model training. So you're going to use, let's say, SageMaker, but you can swap it out and use any other ML platforms, right? You can even use scikit-learn. Develop models in a notebook, right? So this is model development process. You don't really need a lot of computing power at this point, but you're basically just writing the code, developing the pipeline, right? And then you're going to send the model for distributed training. So this is where you can do large scale model training and parameter tuning. You can do distributed parameter tuning using SageMaker, and it's just a bunch of API calls. It's actually not that hard. But imagine like, you're just following this to build your own project, right? You don't have to use SageMaker, of course. And then you're going to use some sort of libraries or algorithms to do distributed model training, right? With SageMaker, everything is saved in Docker containers, right? So it has essentially a more distributed version of these classic machine learning algorithms and deep learning algorithms. And then you can use that for large scale training. And then after the training, you're going to save the model artifact back to S3. And that's taken care of by SageMaker as well. But the model is packaged and saved back to a data store. In this case, it's Amazon S3. But if you work with a model registry tool, you can save that to the model registry tool. That's probably also using Amazon S3, right? And then after the model has been saved, we're going to do prediction. So imagine you're going to do the batch prediction. Let's say you have millions of users and you would like to generate, churn prediction score for all of these users on a weekly basis. That's when you're going to use batch prediction, right? Now, doing batch prediction requires a few things. First of all, the models that you've, packaged, and you need the feature, right? The data is coming from Amazon S3. And you also need the model inference environment, right? And you need to make sure that the model training environment and the dependencies and also the model inference environment is exactly the same. And Docker is probably the best for that, right? So in this case, you need to go find the Docker containers you built, right? Or the Docker image and load that into your inference infrastructure and load in the data and load in the model as well. And then use that for model prediction and save the data back or the prediction back to your data store, right? And if you're doing real-time inference, in this case, you basically need to have exactly the same environment that you use for model training. So you're going to spin up a Docker container as well and load the model artifact. And of course, in this case, you have to write your inference API. You can use Python, Java, whatever language you want. And with SageMaker, it's just a couple of lines of code. And you can have a prediction endpoint. You have to deploy that, right? So this is not a full end-to-end model building process, but it covers most of it. And after you deploy the model, you probably would like to do monitoring. And it would be great if you can do some sort of, build some cool application. Because if you're building NLP model deployment, and maybe you're building a mini chat GPT yourself, you definitely want to build some sort of simple UI so you can actually start to demonstrate your application. And you can make it available on the, on the internet, right? So you can deploy that to Google, Google Cloud environment or, Amazon. So you can use tools like, Streamlit. There are also some other options. Or if you happen to know front-end development as well, you might as well just build something cool yourself. Okay. All right. So I think we're pretty much at the end of this presentation. I would like to briefly mention that WeCloudData has a machine learning engineering, diploma program, and it's the bootcamp, that part-time bootcamp that runs for 6 months. We teach students all of these concepts and also help student practice by working on portfolio projects. And this cohort starting March, we also allow the student to work on real client project. So it's included in this package. And 6 months after graduation, we also provide, the program itself is 6 months, and we provide additional 6 months of career mentorship. So you'll be working with a data scientist or ML engineers for about 6 months, and you'll be able to get a job, in 6 months. In terms of the bootcamp, I think I've shared the curriculum already, but we cover ML, we do ML review, and then we move on to deep learning, computer vision, natural language processing in the first semester. In the second semester, students will be deploying the models they built in the first semester. So this is when you're going to learn how to train, package, serve, and monitor models in production. And after graduation, you can work on real company projects and then receive one-on-one career mentoring. So if you're interested, come and talk to us. And lastly, I would like to mention that, one of the big advantages of going with WeCloudData's bootcamp is the industry mentorship and also the real client project. So that helps you fill the experience gap. And we helped a lot of students land data science and machine learning jobs in the past. All right, so it's time for AMA. If you have any questions, feel free to ask. I'll be online for a while, so start asking your questions, and I'm all ears.
Hello, quick question. You showed the data about the popularity of MLOps and machine learning engineers in the beginning. I'm just wondering how it compares to data engineering, and if you have also the data about the number of vacations for positions for data engineering in comparison with ML engineering. Thank you.
Sorry, I was on mute. I don't have it off the top, but I can tell you that right now in the job market, for every 5 to 7 data scientist jobs, you'll find a ML engineer job. So there's like, if there's 100 data scientist jobs in the market, you'll probably find 20 ML engineer jobs. And then there are about 100 data engineer jobs. And sometimes you'll find more data engineer jobs. And the reason is because, as I said at the beginning, data science is getting more specialized. A lot of the data scientist jobs, it just got renamed into ML engineering or data engineering and, and some other job titles because it's getting more specialized. It doesn't mean the demand for data science is decreasing. It's just like companies realize that we need a lot of data engineers to help us, figure out data. And companies also start to collect more and more data from different, disparate sources when they go through digital transformation, right? So data engineering becomes more and more important as well. But definitely there are more data engineering and data science jobs out there compared to machine learning engineering, because ML engineering is very specialized and it's more advanced version of data science, data scientist, right? So usually the bar is higher, the experience requirement is higher. So that's why you see a lot of data scientists switch into machine learning engineering. So definitely there will be always fewer ML engineer jobs compared to data science. Now, the good thing is that there are not many qualified people out there, right? When it comes to data science, it's very competitive, right? And the entry bar is lower, but also that's why it's also more competitive. And most of the people will not, coming from a tradition, let's say if you're a career switcher, and it's probably better to get started from data science. And once you get some data science and machine learning experience, you can consider ML engineering. Going from let's say a non-tech background to ML engineering will be really hard, but you might as well just get into data science first. And if you really are interested in machine learning engineering, MLOps, then you can consider upskilling yourself.
Thank you.
No problem. Yeah, so this session is being recorded. So we'll upload this session to YouTube. So you'll always have access to a copy of the presentation. Any other questions? Feel free to ask.
I'll jump again. You mentioned the projects, like capstone projects. Can you give an example of what that can be? Maybe I missed that, but yeah, I don't know.
Yeah. To build a capstone project for machine learning, I think you need to find a use case, right? Because if we're talking about ML engineering, it will be great if you can build some sort of ML applications and deploy that, right? So let's say if you want to build, actually, for example, ChatGPT is pretty popular. So we're actually teaching ChatGPT and generative model. One of the small projects students will be working on is actually using Python and Fast API to build an inference engine like basically building a chatbot, and then that chatbot interacts with the ChatGPT API, right? So you're not really training the large foundational model yourself, but it can leverage that. But in this case, you're not really just learning how to work with the ChatGPT API because that's super simple, right? But you're learning how to build a chatbot and deploy that. So that's the ML engineering part or MLOps part. And another idea I can give you for end-to-end ML engineering project is try to find some interesting data sources, right? It could be like Twitter data, which is real time. So you're probably going to use NLP to train some sentiment classification models, but see if you can build the infrastructure in the cloud so that it can collect real-time tweets, right? And when tweet comes in, when your Python application collects the tweet, can you send that to an ML model or NLP model you trained and deployed as an API and call the API to generate real-time sentiment analysis prediction, right? But after the prediction, where do you save the data to? So you have to think about a use case. Are you building some sort of Streamlit application? Or if you know front end, back end, let's just build some very simple application. So chatbot could be an interesting use case in this case, but it doesn't have to be computer vision NLP because it could be using Apache Spark to do batch data inference. So you can train a model and deploy the model, and then use Spark. You use a different function to generate the prediction as well. So in that case, you may want to leverage Apache Spark and Databricks for that purpose, or you can launch your own Spark cluster in Amazon Cloud. So whatever end-to-end project you work on yourself, it always touches on the data infrastructure. So you definitely need to know like how to work with AWS, how to set up different services. If you're using Docker, you need to know how to deploy the Docker, let's say to Amazon ECR service, Elastic Container Registry, right? And you can even deploy your model using Amazon Lambda function. So yeah, there's quite a bit engineering and also like system related, skill set you need to build up.
Thank you.
How do you foresee the impact of GPT on machine learning engineer and data science jobs? That's a good question. I don't think it's going to have much impact, at least in the near future. I don't know how powerful ChatGPT will eventually become, but it's just a huge transformer and generative model, right? So it just essentially just predicts the next word. So in this case, it's not that intelligent, to be honest. It just has seen so much data. I think the limitation of ChatGPT here is that, let's say you want to do data analysis, you want ChatGPT to automate that, right? It can do some very basic stuff, such as, for example, hey, ChatGPT, can you write some scikit-learn code for me that trains a classification or XGBoost model? No problem. ChatGPT will write the code for you. And then it's not going to be 100% accurate, but if you copy the code and paste that into Jupyter Notebook, you tweak that a little bit, it just saves you time, right? However, ML engineering and data science, the most important part is not writing that code. That code can be standardized. It basically just reduces the time and for you to do to Stack Overflow and Google. It saves you time, makes you more productive. But would you upload your company's data to ChatGPT and ask ChatGPT to actually just look into the data and help you find issues in the data? I just don't think this is possible, right? Most companies will eventually prevent you from doing that, or even just ban ChatGPT, unless it's some sort of internal generative models that work like ChatGPT, which is super tuned for, fine-tuned for your particular industry. I think that's possible, right? But you're definitely not going to upload your company's data and let the ChatGPT actually do the training for you. So if that's not going to happen, I don't think ChatGPT will be that smart when it comes to replacing your job, because it can write boilerplate code, but it doesn't really help you actually, look into the data. So I think the value of a data scientist is actually on the analytics side. You actually need to look at the pattern. Unless ChatGPT can do that, And then I think it may actually be able to replace data scientists, but I don't think it's gonna get the private training data that easily. The reason why ChatGPT is actually better than the Bing version of GPT is because it's the same technology, same company, but it took it 1 to 2 months to reach 100 million users, and there's so many people submitting questions. That is a very unique data, and it can use that to fine tune, do reinforcement learning. It has a huge team of people who label the data as well, right? That makes it intelligent, just like Google has its own proprietary data that it collects from people through Gmail, through Google Map, through Chrome, right? So that is something that's hard to be replaced, I think. But yeah, so and the new Bing service, I'm not sure if you guys worked with it. It doesn't work as great as ChatGPT. It's because it's relatively new. It hasn't reached that level yet. After a few months, I think it will be a lot better. But these are all public data, right? Private data, I think it will be hard. But I start to see company like start to fine tune this for a specific industry. That would be interesting. So yeah. I don't think I have that much knowledge just to predict the future here. But if you pay attention to Twitter, I think one of the godfathers of deep learning, he's the VP or whatever, head of AI at Facebook, right? Young. I think he's not a big believer of ChatGPT because he said there's nothing revolutionary. And it's interesting to watch some of those debate on Twitter. So my answer is no. I don't think in the short term it's going to replace data science job. It's nowhere near that. But very low level stuff, for example, writing scripts, that indeed saves you days and even weeks of time. But you still need human who actually have the domain knowledge to tell if that's legit, if that's good. So it saves you time, right? So you can use that to write, let's say, sales, cold calling, messages. If you're for marketing, posting social media messages, writing SEO articles, that will save you a ton of time. Data science is still a bit hard. And when it comes to data science and data engineering, I remember when I start to work with machine learning back in 2008. There were already automated machine learning tools out there like KXCN. It was quite expensive and it pretty much automates the end-to-end process and the model performance is great. But I haven't seen it taken off. The market share is super small and it's probably, I don't know if it even exists nowadays. It's because, you can just automate the part of it, but it's not the real value of a data scientist, right? And the business is always way more complicated than we thought. So, yeah. What advice do you have for someone learning machine learning to be a freelancer instead of working for a tech company? Yeah, so my advice for freelancers will be you need to build your personal branding. Unless you join some sort of agency. I've seen a lot of companies like that. We hire machine learning engineers for projects sometimes, and then we worked with freelancing, like companies that provide freelancers. And I think if you're going solo yourself, you absolutely need to build your personal branding, right? The hardest part of getting your first machine learning freelancing job is, why should I give you my data, right? I know there are a bunch of I think boot camps out there. They help their students to get some sort of projects, but they eventually stop doing that because it's way easier for a UI UX boot camp to get the projects for students, because you don't really have to touch the core data or whatever infrastructure of that company. And they say, okay, let's have a meeting. This is your existing application, your website. I can build something completely new for you. And then you can just, spend 3 months building that. And the company, if they like it, they can use it. If they don't like it, they don't really care. They're not really spending a lot of time with you, right? But when it comes to data projects, it's always, privacy is always a concern. Why would a company trust you and give you the data and also spending the time explaining all of their data rules and policies to you if they don't know how capable you are? So you need to start building your personal branding as early as possible, That means not just GitHub, writing some blog posts, right? Getting people's endorsement on LinkedIn. So you need to start building that, and even YouTube videos, right? Start to build your expertise, and when you reach out to people so they can see your work. And that's why portfolio project is also very important. And once you get your first project, the second project will just keep coming. I think it will, so the first one is always the hardest. Yeah. And of course, you need to leverage those freelancing platform to find the work. Any other questions?
I may just add an opinion about the ChatGPT.
Yeah, go ahead. It's a hot topic.
Yeah, that's exactly what I was going to say. Because it's so hot and so many people are talking about out of tech, the chances are that a lot of CEOs or like executive of companies will hear about that, and they'll be asked, like, do we have machine learning in our company? And they will want it internally.
Oh, absolutely. That's something I already start to see, because those executives will get so excited and let's do that, then it will become a hype. But it's interesting. It's going to just generate more demand. I think
that's what I was going to say. Like
yeah.
it's good for us.
When GitHub Copilot, right, and also Codex from OpenAI got released, a lot of people will say, well, it's going to replace software engineer jobs. Actually, it creates more demand because it automates a lot of low-level stuff. I start to see software engineers actually heavily using Copilot. I heard it was like 60% of the code written is already using Copilot. I can't believe that, but it's quite high. Yeah. So people are just becoming more productive, to be honest, and you can focus on the more advanced tasks, which is good. And because even internally at WeCloudData, we have challenges. Like, for example, we have limited resources. We have developers, right? We're building learning platforms. We're building internal tools, and then when you have a small dev team, you're doing your yearly planning. You realize, okay, we can only build these 10 features, right? But if those 10 features, part of the code can be automated and we can build that in two months, we're never short of ideas. Like, there's so many new things we can implement. It's just like, I know we have limitations. We can only build these 10, right? With the limited amount of resources. But imagine, these tools will make your developer more efficient. Then you can actually, the demand for building tools and features are always going to increase. It's not going to decrease. Is fast API necessary to learn? I have little experience in web development. So I don't think fast API is the best web development tool, first of all. Python, there are a lot of good applications that are originally built in Python. Instagram, Dropbox, right? YouTube was even originally written in Python. But I don't think at this scale they're using, the people still use Python in a lot of places, right? But if you are talking about web development, then maybe JavaScript, right? Python is something I would recommend, like fast API for ML engineers, especially ML engineers who don't come from software engineering background, right? And you want to learn the basics of web development, REST APIs, microservices, because that sort of is the knowledge you need to have in order to get the job done. But still, ML engineering is not like web development or software engineering. It's still different, right? You're not really building large scale applications. And most of the time, you don't care about UI front end, right? You're building that API. And you can certainly use fast API to do that. And you can scale that using, Lambda functions and other, Docker containers running on EC2, right? So it fits most of the use cases. But for 5% of those use cases that actually require really low latency, then Python is probably not the best choice, right? And it also depends on the actual backend language the company prefer. And a lot of times the choice of language is just a culture. You know, there are data engineering organizations that you have to use Scala, but there also, I've seen a lot of data engineering team that purely use Python and PySpark. So they just believe in different things. Some companies prefer efficiencies or, you know, just the ease of, you know, learning. But some other companies are more hardcore. They want the performance, right? But the cost of getting those talents is also higher. I think that was a while back. I watched a video or whatever presentation by I think the lead engineers at Shopify, and it was saying that, well, we use PySpark internally, and people asked him why. He said that's because we can't find enough good Scala developers, right? But it may have changed now, but you know, when companies choose a language, there are a lot of practical considerations. So learning fast API is worth it if you don't come from a software engineering background, if you don't know Java, you know, and the cost of learning Java is very high, and you may not get to apply it because when you join a lot of the startups, they're probably not using Java. So in that case, like, you know, just knowing fast API and to practice and learn the principles of building APIs and working with backend languages, that will be very helpful. But ultimately, you are the ML engineer. So your task is to focusing on machine learning and deploying. That deployment piece, right? You're not going to write a ton of code. But unless you're working for companies like Twitter, then you have to use Scala. Most of the code written there is Scala. But yeah, I think for most of the startups and companies, fast API will be good enough. But it also depends on the language company use.
Just to add to that, like if you think that not knowing web development will be limiting you, like I'm talking about like front end, will be limiting you from learning fast API, you don't need front end knowledge of front end whatsoever to learn fast API because it comes with Swagger. Everything is included. You don't need to write any HTML, JavaScript.
Yeah, it's more backend, so you don't need to worry about the front end stuff. Yeah. But I think if you want to build some really interesting like portfolio project, knowing some front end will be helpful, but it's probably not worth your effort at the very beginning because you know, you don't want to distract yourself because there are tools such as Streamlit that allows you to build some sort of ML applications, and it takes care of the front end. All right, I think that's all the questions I got. Again, if you're interested in learning machine learning engineering, WeCloudData has a machine learning engineering bootcamp. So down the road, if you ever consider bootcamp, you know where to find us. So I hope you guys enjoyed this session. The recording will be uploaded to YouTube, and I'll tell you, you know, where to find us on YouTube. It'll be youtube.com/WeCloudData. There are a lot of event recordings there already. We have DevOps videos, data science, data engineering as well. So I hope you